In this lecture, we are going to discuss about one of the special kinds of concrete, that is lightweight aggregate concrete. So, what is a lightweight aggregate concrete? Why should we use lightweight aggregate concrete? And what are the different ways of manufacturing a lightweight concrete? And what are the different properties that are going to influence the different kinds of lightweight concrete? This is all we are going to discuss in this video lecture. So, one of the disadvantages of conventional concrete is its high self-weight. So density of a normal concrete is in the order of 2200 to 2600 kg per meter cube. This heavy self-weight will make it to some extent an uneconomical structural material. So attempts have been made in this past to reduce the self-weight of concrete to increase the efficiency of concrete as a structural material. So in this scenario, we have come with the concept of lightweight concrete or lightweight aggregate concrete. So what exactly is this lightweight aggregate concrete? We are reducing the density of the concrete. Lightweight concrete is a special concrete which weighs lighter than the conventional concrete. Density of this concrete is considerably low, such as 300 kg per meter cube to 1850 kg per meter cube. When compared to the normal concrete, that is 2200 to 2600 kg per meter cube. There are three different ways in which you can manufacture lightweight concrete. First one is lightweight aggregate concrete, next is aerated concrete, next is no fines concrete. So what is lightweight aggregate concrete? When we are going to use any kind of aggregates that are light in weight, that are lightweight aggregates to manufacture concrete, we call it as lightweight aggregate concrete. So what exactly is aerated concrete then? If at all we are introducing gas or air bubbles in the mortar, this is called as aerated concrete. Then no fines concrete. If at all we are omitting the sand fraction from the aggregates and we are manufacturing concrete, you call it as no fines concrete. So generally lightweight aggregate is popular in UK, France and USA, and aerated concrete is popular amongst Scandinavian countries, and no fines concrete is very much less popular. So what are the advantages of lightweight concrete? First one is it reduces the dead load. That is, when you're calculating, when you're designing any RCC member, the first load we take is dead load, that is self-weight of the member. It gets very much reduced. So, and it is because the dead load of the concrete is less, it is easy to handle, and hence it reduces the cost of transportation and handling. This also improves workability and relatively low thermal conductivity and comparatively more durable but less resistant to abrasion. It has been applied in prestressed concrete, high-rise buildings and shell roofs. It has a very good resistance to freeze and thaw action when compared to the conventional concrete. It also helps in disposal of industrial waste like fly ash, clinker, slag, etc. So let us see the three different kinds of lightweight concretes. First one is lightweight aggregate concrete. You are replacing the conventional mineral aggregates by lightweight porous cellular aggregates. That is how a lightweight aggregate concrete is manufactured. Aerated concrete. You are introducing the air or gas bubbles in the concrete. Next one is no fines concrete. You are omitting the sand fraction in the concrete, and without the sand, if at all you are manufacturing the concrete, you call it as no fines concrete. So basically, if at all we see about the lightweight aggregate concrete, the key ingredient here is lightweight aggregates. So if at all we look into that lightweight aggregates, there are two kinds of lightweight aggregates. Those are natural lightweight aggregates and artificial aggregates. So natural lightweight aggregates are less preferred over artificial aggregates because in artificial aggregates we ourselves manufacture them under controlled conditions and expected results. So natural aggregates are pumice, diatomite, scoria, volcanic cinders, sawdust and rice husk. So this picture shows you how a lightweight aggregate looks like. If at all you see, it is all cellular and porous. It is clearly visible in scoria because it is porous cellular structure. So let us see about each one. So pumice stone, it is an volcanic origin stone. It is also used in this general daily lives. It occurs in different parts of the world. They are light enough and yet strong enough to be used as lightweight aggregates. Their lightweight is due to the escaping of gas from the molten lava when erupted from the deep beneath the earth's crust. Pumice is usually light in color and these are nearly white, and which is a very fairly even texture of interconnected cellular structure or interconnected cells. Next one is diatomite. So what is a diatomite? Diatomite, it is an hydrated amorphous silica which is derived from the remains of microscopic aqua plants called diatoms. Scoria is also an volcanic origin which is usually dark in color and contains larger and irregularly shaped cells unconnected with each other. Volcanic cinders, these are also a loose volcanic product resembling the artificial cinders. You know about rice husk, but it is of a limited use. So limited use of rice husk, groundnut husk and bagasse have been used as lightweight aggregate for the manufacture of lightweight concrete for special purposes. So even sawdust can sometimes be used as lightweight aggregate, that is natural lightweight aggregate. Next one is artificial aggregates. So if at all we see artificial aggregates, there's a shale, slate, perlite, vermiculite, etc. So and even brickbats, cinders, clinkers, foamed slag, blotted clay, this can also be used as artificial lightweight aggregates. So this type of aggregates decides the density of concrete, and density of concrete can be as low as 300 kg per meter cube, and the compressive strength, it varies from 0.3 megapascals to 40 megapascals. Properties of lightweight aggregates. Pumice and scoria are volcanic rocks having densities between 500 to 900 kg per meter cube. Natural aggregates have good insulating properties but subjected to high absorption and shrinkage. Lightweight aggregates have higher apparent specific gravity than conventional aggregates. Properties of artificial aggregates are less variable than natural aggregates. Lightweight aggregates have a tendency to absorb more water than conventional aggregates. Semi-lightweight concrete with normal fine aggregates and light coarse aggregates is better than all lightweight aggregates. In case of RCC structures, increase the cover by 10 mm extra to avoid corrosion of steel. Let us see the mixed design of lightweight concrete. It is difficult to decide the water cement ratio. Generally, with experience, you will be having a very good idea of what is the water cement ratio that has to be chosen because of the different or variable water absorption capacities of the aggregates that are available. Generally, it is done by trial mixing. Pre-saturation of aggregates is done to avoid excessive absorption of water by aggregates. Concrete with saturated aggregates will have higher density, which is bad in freezing and thawing action. In rare cases, aggregates are coated with bitumen to overcome the water absorption problem, because bitumen is a very good repellent to water. Next concept is aerated concrete. It is produced by introducing air into the concrete. It is also called as cellular concrete, having voids between 0.1 mm to 1 mm in size. There are two ways in which you introduce air into the concrete, that is gas concrete or foamed concrete. So it is generally produced by chemical reaction in which gas is produced in the concrete. finely divided aluminum powder, if it is generally used in the concrete, it will react with the calcium hydroxide that is present in the concrete, and it will liberate some hydrogen gas. This hydrogen gas, when it is trying to escape of the concrete, will create some small fine porous holes, and because of this fine porosity or holes formed in the concrete, you will be having a very good interconnected cellular structure, and as therefore we will be having a very lightweight concrete. Next one is no fines concrete. This is the third method of producing lightweight concrete, in which you omit the fines from the conventional concrete. No fines concrete, as the term implies, is a kind of concrete from which the fine aggregate fraction has been omitted. This concrete is made up of only coarse aggregate, cement and water. Very often, only single-sized coarse aggregate of size passing through 20 mm and retained on 10 mm is used. No fines concrete is becoming popular because of some of the advantages it possesses over the conventional concrete. So this is a brief introduction or a brief lecture on the lightweight concrete. Thank you.